Hello and welcome to this shortish lecture on FSC 30013 Introduction to Forensic Geoscience. So my name is Jamie Pringle, I'm the module leader, so I'll be the primary contact if you've got any queries on this module. There's a variety of guest lectures also because it's a specialised area later on in the course. This picture is taken by my colleague Lawrence Donnelly in Eastern Europe, I think, around the Bosnia area, showing a surface deposits. This is basically what we're not looking to find. Certainly we're going to be looking for the much more tricky parts of forensic geoscience.
Okay, so for section logistics, the course format will generally be two sort of interactive lectures per week. There'll be some quizzes with those. And I've also got some pre-records and asynchronous resources for you to look at as well. There's a sway on the VLE and there's other resources as well each week in a folder. Now, assessments wise, there's only two in this module. Assessment 1 is a student-led group practical element, which you'll be able to choose your own groups, click data in the field and then write it up as a group report, which you only submit one of those per group. And get feedback. There's also a peer review element as well to encourage participation. The second assessment is a individual trace evidence report, which is the other 50% of the module, and you can read a bit more or listen a bit more about that in the assessment folder.
So here's our draft section then or structure of the module. So there's going to be a couple of lectures each week. With those roughly, hopefully there's that same order. Some staff may have clashes, in which case I need to move them around a bit, but that's the general plan. There's obviously the labs side of things as well. It's that second column, which I've tried to give you sort of a rough idea of what to do each week, if that's helpful for you. This will often, as I'll talk about in a moment, depend on when you're doing your outdoor lab, but you can obviously do the other two at any time, so don't feel you've got to do things sequentially. And then with the assessment side, depending upon when you do your group project, it'll depend upon when you submit it. So I'm trying to be equitable to all the students. So it's 3 weeks and a couple of days after your practical that you've done in the field is your deadline for your group report. You've got your virtual trace report during on week 9, and then your individual lit review assessment during in week 12. That's sort of the 3 assessment deadlines. I've tried to space them out for you. Okay, now I have tried to be organised, and I've got pre-recorded short lecture versions. They're not a full version. They're just like trying to be 20 minutes ideally. As you can see, some of the times there are some of the key slides or theory lectures that are already up there. You may need to look at those if you've got an early group. For example, you want to know about soils and what types there are and why is that important, and you may need whoever's in your group team who's been charged with looking at that to maybe watch that first, or maybe the geophysics lecture as well. Perhaps it's up to you, but that's all there for you to look at and enjoy. Hopefully that's useful. I've also done a sway background resource section as well, so you've got plenty of resources there that you can look at, as well as the library list. Of course, that's up to date also on the VLE link, and there's some sort of YouTube guides I've given on how to I don't know, things like contouring resistivity data for your group project, for example. There's links to conversation articles on topical news things that have come out recently. So I've tried to keep that relatively up to date. So your first assessment, then there's a separate short pre-recorded on this lecture, so do read that. But briefly, it's a group-based problem-solving exercise. You've done a little bit in the field, but probably not a lot, so you're going to be doing a bit more of that. It's not just geophysics either. There's some other techniques to use, so give you some basic knowledge of that and how to apply it. And who knows, you might be inspired to do that. Look as trendy as me there in that photo in your future career. I have done a sort of a pre-practical orientation thing, so it's like a virtual look at the site and the different bits of kit that you could use. Okay, so that might be quite useful for you. So have a little read about that. Seems to be two working together here. And then your objectives is to look at non-invasively. You're not going to be doing any digging. Investigate a suspected area. Maybe reading up on some key skills that you need, some background reading, and deciding what you want to use first with some sort of techniques as a group. And you can do that as a group-based outdoor work, and then you're going to be working up the data afterwards submitting a project. The second assessment is looking at more of a virtual case. So we're looking at Keele Church Graveyard, looking at some data I've already sort of got for you to work up with, but it's up to you what you look at, whether it's whatever elements you want to look at or items based on the data you have. And again, do read up or listen to me talk about this in a separate pre-recorded session. And then there's obviously a deadline of week 9, as I mentioned, based on that report. So I've done a lot of the hard work for you. So already collected soil samples, dried them, measured them with the XRF, both in the field and in the lab. So you've got some ideas of what you want to do. All of these assessments have separate guidance and marking criteria for you, so you can have a little read about what I'm expecting, how things should be structured, what should be in each topic, just to give you that sort of real help and advice, which sort of feedback from previous years I've found useful. The marking criteria is also there for you to look at to see how to get those top marks, which you should all be aiming for. So do have a little read about those and making sure you've got everything in that system. That should be helping you to get a better mark. So do try and map your reports and assess work to be making sure you're covering all of the different items that we're looking for in such a report. These are one of these really useful employability skills that you'll need come job time. So what is forensic geoscience? Well, geoscience, science of the ground, could be on a variety of things. So this sort of chopping up stuff, obviously that's sort of forensic pathology, digging up graves, that side of things, that's sort of more archaeology or forensic archaeology. CSI stuff, as you know, can be either not invented yet or the time frames have been compressed. But X marks the spot does happen. People do in the past, mark sites where they've buried things, so that's quite true. But forensic geoscience is using geology and the wider environmental science information and methods to investigate sort of things of interest before coming through a court of law, and that could be either criminal or civil courts. So you can imagine sort of illegally dumped wastes, environmental contamination, that side of things. It's not all about buried people, it could be other things as well. Sort of principally concerned with studies of rocks, sediments, minerals, soils and dust using analysis and some sort of non-invasive geophysics or satellite data, even so remote sensing data. So it doesn't have to be all physically on the ground yourself. And as you'll see in the course, as it's a big area, we're going to trying to look on 2 main sites. So search, as in looking for things, and then the trace evidence sides, once you found something, trying to see what the forensic geoscience evidence of that could be. And it's quite multidisciplinary, so we've got a lot of different sites. And here I'm on the best part, obviously the geophysics, the top left side of things, physical properties of the ground, geophysics, briefly. There's other ones I've shown you, covers it a little bit, I guess. Chemistry covers it a little bit, biology covers a little bit, and engineering on the sort of fatal accident side of things, I guess, engineering side. So it's quite a broad ranging subject area. And it's come all the way back from sort of 100 years plus, a sort of Sherlock Holmes writer, talk a bit about sequential accumulation of soil layers as someone's walking through different fields to try and work out where they've come from. Very important. Hans Gross, a German guy, was the first published sort of a forensic geoscience handbook, so that's in the 1800s. And George Pop, he was the first sort of published case using mineral evidence to link to a suspect. I think it was a strangulation case of Eva Dish, and finding this unusual mineral in the soil was linking to the suspect. So it's quite useful. And then a case a couple of years later with Margaret Filbert is actually matching different soil types to sort of police theories of how things have moved, as I've mentioned earlier. And this French detective, that side of things, and certainly with increasing sensitivity of equipment, smaller and smaller items being able to manage, it's certainly useful, and that's the case in the forensic geoscience world as well as the larger sort of forensic science world as well. For example, this case in the 1912, someone was strangled to death, I think, and then the face powder of the the lady was strangled and was found under the suspect's nail contents. And in those days, face powder was quite specifically made. It's mineral called talc, could be found in specific quarries getting mined, then becoming in certain products. So you can actually try and link back where this material was and what's it made from and which type. These days, a lot of things are homogenized or from the same area, so it's a bit harder, but certainly older types are quite true. All sorts of stuff in here. So this was an interesting sort of Second World War case where these so-called vengeance bombs were released in Japan and travelled across the Pacific Ocean to land in the US and start fires. That was the idea anyway. And when they were released, they actually took sort of beach samples as ballast in those little bags, and the military geology unit in the United States Geological Survey at the time were actually trying to work out where the beaches were that they were being released from, with the effect that they were actually the US Air Force bombed those sites in 1944. In fact, there was a blackout on actual whether this worked or not, so they stopped doing it anyway. So it wasn't a success, but it's quite interesting. And after the war, they found out they're releasing them for 3 different beach sites. So recent cases of using forensic geoscience. So Aldo Moro was an ex-Italian prime minister. He was actually kidnapped and murdered. His body was found in the back of a car with some beach samples to try and throw the police off the scent, to think that he was actually kidnapped and held on a beach. Louis Mountbatten, he was Prince Charles's uncle, got blown up by the IRA in 1979 on his boat in a lake in Northern Ireland. And they actually used sort of the sand and the paint flakes from the boat as evidence to convict the perpetrators. And lastly, Stephanie Slater, who sadly died. She was a estate agent who was showing someone around her house and disappeared and was kidnapped. And a ransom note was attached to a brick. And in fact, the brick was quite unusual. It had some anorthite minerals in it, which was actually the detectives worked out was delivered to this new estate being built in Birmingham where she was actually held. And I think that was a couple of weeks behind the other case. I can talk about that later on. Ian Huntley, you might have heard about. He's quite infamous. His car was linked to the discovery of these 2 schoolgirls who'd been kidnapped and missing and found sadly dead in Suffolk. So he was the janitor, I think, at the or groundskeeper, whatever, handyman in the primary school where the girls went missing from. So his car was seized. He'd cleaned his car, but he hadn't actually cleaned under the car. So the car arches, there was some chalk fragments in there, some sort of rock fragments, which on analysis was actually worked out to come from a specific small area in Suffolk where the crime scene was located. And once he was presented with that evidence in court, he actually changed his testimony to say from he hadn't been there to he'd gone past that site for whatever reason. There's also some botanical evidence as well to suggest he'd gone twice, looking at the different seasonal changes in the spores and pollen, which is interesting. So we chatted to the people who'd worked on that case a few years ago now. Peter Tobin's another one, if you've heard of him. He's currently inside for the murder and illegal disposal of a body. Actually, that's a separate crime, of a Polish teenager found under a church's floorboards in Glasgow. But they started to look at previous unsolved cases where he'd lived in the past, one being in Margate in Kent in southeast England, and the neighbours who still live there, actually, of where he used to live, on that plot on the top right, had said he'd gone out at night and was digging a pond or something, or digging holes, and didn't actually have a pond. Which is a little suspicious. So at that time, the Metropolitan Police Force, I think, had their own geophysics team, sadly disbanded now due to cost cutting. But they did a GPR survey and found some interesting anomalies in there, which they carefully dug down and found the bodies of these 2 missing schoolgirls in the 1990s. And because they'd been careful, they could find the bloody thumbprint of Peters on one of the bags containing the bodies. So that was used to sentence him for murder as well. There's a link there if you're interested. Other areas of interest, so there's a couple of divers in a lake in Cumbria had found the weighed down skeleton of a female in a lake. Been missing 20 plus years before. Apparently she'd run off, apparently, according to the husband. Hadn't been seeing them again. Obviously no DNA evidence to support that, but unusually the body was weighed down with these large sandstone cobbles, so large fragments, which weren't from the local area, so they were thin sections, so thin slices were cut and then looked at down a microscope, which is what you can see on the right hand slide, and the bottom two look pretty similar, just looking at the colours and the sizes of the fragments making up the sandstone, which were linked, one of them being from the weighed down skeleton and the other being from some fragments in the back garden of the family house, so that they used that as part of convicting their husband of the murder. We'll talk a little bit about some controlled studies, so we're working out, where things are, either in graveyards or you do controlled studies of pretend clandestine graves, basically. So this is in the back garden of the Staffordshire University's crime scene house. There's a couple of things we buried in there, and we survey them over time to see, could we detect things if we didn't know where they were, and is there a temporal effect, does it change over time? So we'll show you some of those results. Forensic botany is quite interesting. I don't know if you know much about that. It's quite useful in different sort of plants live in specific areas, and combinations of them make those areas more unusual. There's a seasonal change, as I mentioned earlier, so you could try and work out if someone's dug down and there's some spores and pollen from it when they buried it, perhaps. And there's some unlikely scenarios like that top right schematic of cutting down the tree and then working out from the tree rings the sort of minimum age the body's been down, as well as some more other interesting areas. Adam Torso, for example, this Nigerian, they found out, victim found floating down the Thames in the early 2000s, and working out from its stomach contents what their last meal was and what potentially happened to them. Diatoms, Michael will talk a bit about. Unicellular algae live in very specific areas. They tend to die off really quickly, really good preservation potential. Loads of different types out there, can be really useful for all sorts of things. You've probably seen the classic test for drowning, the diatom test, whether it's got diatoms in there. Doesn't tend to be diatoms in the UK water supply. So if you do find someone drowned in a pond, for example, and they don't have any diatoms in the lungs or deeper into their bloodstream, it could be they've been drowned in the bath and then moved to the pond and dumped. So that's quite a common test for drowning. We also talk a bit about environmental forensics, so talking about studies where people have illegally dumped stuff. So this is a case we worked on a few years ago in Northern Ireland, where people were breaking up stolen cars and dumping loads of material in sites of triple SIs, special sites of scientific interest, Site A, for example, in here by the river. So real big problems, and it's quite lucrative. You can get paid a lot to get rid of stuff, and then you're just dumping it illegally. So it's and with a low chance of getting convicted, although not in this case. We did manage to eventually get them convicted of that, because that's what the original height of the field should be. This rural field site. You see how much area this raised bank is how much extra material has been dumped there. So we actually ran around surveying this site and even quantifying how much material was in there for. Certainly environmental thing is a big growing area of interest, and it's sort of high profile pollution incidents. You can use remote sensing techniques to quantify how much is spilled, where it's moved to, and it's fairly unbiased about that for criminal prosecutions. There's a few research teams out there. This is Bournemouth's one, for example, looking at that issue. Exxon Valdez being the most highest profile. It was a big oil tanker that ran aground in Alaska. Loads of crude oil got leaked out, as you can see here. Cost loads of money to clean up, and then the oil company's liable for the sort of criminal and civil damages from the Alaskan government. So a lot of that material's been done. It's not all about environmental things. Wildlife forensics quite a big thing. So again, we've worked on that for a few years now. For example, looking at disturbing badger sets. That's a crime at the moment. And again, could they use scientific evidence to find out what they've done, how much material's been blocked, for example, and that side of things. So we've worked on that, which I think Chris is going to chat to you about in future lectures. So in summary then, forensic geoscience, it might be sort of 100 years old or so in forensic science world, but there's a lot of lot of areas that have been expanding, both in the search side and the trace evidence side, which is what we're going to be looking at, and certainly using a lot of different disciplines into that. And it's certainly going to provide a lot of evidential value for forensic investigations. And what this sort of just introduction really just goes into the sort of specialist lectures you're going to have during the course. So there are some suggested reading. See the VLE for the reading list and book articles. There's some good books on this. The bottom one maybe is the key one, Geoforensics by Alistair and Jenny from Queen's University in Belfast, as well as these other ones as well. So do have a little read through that. Thanks for listening.